Today's video is going to focus on scientific notation, which helps us simplify numbers with lots and lots of zeros, and then we're also going to learn how to expand those numbers from scientific notation to those numbers with lots of zeros. So the first thing I need you to take out is your green unit organizer, and in slot 13 you're going to say scientific notation notes. And you're going to get no score for that. And then in slot 14, you're going to say independent practice, IP, scientific notation. The first thing we're going to learn about in scientific notation is how to simplify numbers with those lots of zeros. So the first thing we're going to do is we're going to count the number of times you're going to move the decimal point, which is always behind a whole number if it's not shown, so that it's behind the first number that's between 1 and 9. You're going to write that number, the one between 1 and 9, and then you're going to add times 10 after it. You're going to write the number of times you move the decimal point as an exponent after the times 10. This is called a power of 10. If you move the decimal point to the left in the beginning, the exponent is going to be positive, and it's going to represent a very big number. If you move the decimal point to the right in the beginning, the exponent is going to be negative. It's going to represent a very small number. Now, scientific notation does not eliminate zeros that are in between numbers, such as 0.1002. So these aren't going to go away. Those zeros are placeholders and are not front or end zeros like the ones we're trying to get rid of. So for example, let's take 3 with 9 zeros at the end of it. That's a really big number that we can simplify using scientific notation. So our first step was we're going to count the number of times we're going to move the decimal point. Now, I don't see a decimal point here, but I know it's always behind the whole number, so we're going to add it in. And I need it to go here, because that's going to be the first number where it's going to be between 1 and 9. So I'm going to move the decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So I moved it 9 times to the left. So because I moved it 9 times to the left, my exponent is going to be positive. So using my second step, I'm going to write that number, which is 3, and add times 10. My third step was write the number of times you move the decimal point as an exponent. Now because I moved it to the left, it's going to be positive. Because I moved it 9 times, it'll be positive 9. So I just simplified 3 billion into 3 times 10 to the 9th power. Going to example 2, I see that I have a decimal, which means it's a very small number. So here's my decimal point, it's already there for me, and my goal is to get it in between this 4 and 5, so it can be a number between 1 and 9. So I'm going to move the decimal point 1, 2, 3, 4, 5, 6 times to the right. Now my first step says count the number of times you move the decimal point, which I did, and we moved it 6 times to the right. Now I'm going to write the number, the one between 1 and 9, which is 4.5, and I'm going to add times 10 after it. Now I moved it to the right 6 times. So if it's to the right, it's going to be negative, and I moved it 6 times. So using scientific notation, we changed 0.000045 to 4.5 times 10 to the negative 6. It's really important to remember that this positive and negative exponents doesn't mean that they're positive and negative numbers. It just means it's a direction. So if it's negative, we're going to be simplifying a very, very small number or a number less than 1. If the exponent's going to be positive, that means we're simplifying a very, very big number, which means it's greater than 1. Now we're going to change numbers from scientific notation to regular form. I call this expanding the number. So the first thing we're going to do is we're going to consider the direction the decimal point needs to move, right or left. If it has a positive exponent, that's going to mean it's a very large number that needs more zeros. So again, if it has a positive exponent, it means it's a large number that needs more zeros added to the right of the decimal point. If it has a negative exponent, that means it's a small number that needs more zeros added to the left of the decimal point. So again, if it's a negative exponent, it means it's a small number that needs more zeros added to the left of the decimal point. The second step is you're going to move the decimal point the number of times the exponent indicates. So if the exponent is 3, for example, then the decimal point is moved 3 spots. Let's do it 2 times here. So the first thing I'm going to do is I'm going to rewrite my original number, so 2.45. And my example says 2.45 times 10 to the 5th power. Now it's positive, so that means I'm going to move to the right because I need to make it a big number. So I'm going to move the decimal point 1, 2, 3, 4, 5 spots. And in each of those empty spots, I'm going to put zeros. And I'm going to make it look a little better, so 245,000. So 2.45 times 10 to the 5th power becomes 245,000. There's no units because we're not making it into a problem yet. In the second part, example, we're going to rewrite my number. Now it's 3.4 times 10 to the negative 6th. So if it's negative, we're going to move the decimal point over to the left because it needs to be a very small number. So we're going to move it over to the left 6 spots. So 1, 2, 3, 4, 5, 6. We're going to put zeros in those empty spots. We're going to make it look a little prettier. So we had 1, 2, 3, 4, 5 zeros with 3, 4 at the end. So 3.4 times 10 to the negative 6th power is this number, so 0.00000034. On the very next side of this page, which is going to be page 14, you're going to do this independent practice.